All right, so we're going to develop what the sine and the cosine graphs look like when it's not based upon just the unit circle. Now, all the values are going to come from the unit circle, but what we've done up to now has just been based upon the unit circle. We're going to see what it would look like basically if it was on like an XY coordinate graph. So in order to do that, we're going to fill in all of the different values of sine of theta. Now, again, remember, sine goes with your y value. So basically, you want to reference your unit circle here, and you're going to fill in all of the values. Now, it does say to give decimals. So we're going to go through, and I'm just going to write down the actual unit circle values first. Then we're going to convert them into decimals so that we can actually graph it, because graphing the square root of 3 over 2 is not easy unless you put that in terms of some kind of a decimal approximation. So again, remember that sine is y. So you're going to look at all the y values at all these different unit circle values. So if you go around the unit circle, when you look at angle 0, which should be on the positive x-axis, the y value there is 0. If you look at pi over 6, which again should be in that first quadrant, the y value there should be 1/2. Then if you look at pi over 4, the y value should be square root of 2 over 2. Pi over 3, it should be square root of 3 over 2. And then at pi halves, it should be 1. Okay, if you want to, probably be a good idea, just go ahead and pause the video, fill in the rest of them, and then come back and double check that everything is okay. I'm going to go ahead and fill in the rest of these now real quick, and then you can double check it. But again, pause the video. After that, come back and double check. Okay, so I've filled in everything else. Hopefully you started to realize or recognize again more patterns. You should be able to see that there's definite symmetry here as you go through all this. All right, so in order to graph these, again, it does say to use decimals. We'll come back to that in a second. The first thing you're going to look at, first of all, this theta value up here basically is going to go where it says x right here. So we're actually going to change that x to be theta. Because if you notice, all of these things right here, those are all the angles around the unit circle, or at least most of them. So we're going to go ahead and graph these. Well, 0, 0 should be very simple because that's right at the middle of the origin. That's right there. And then it says pi sixth 1/2. So we're going to go to where it says pi sixth, which is right here. And then we're going to go up to 1/2, and we're going to put our dot. Now, the real question is a couple of different things. First of all, the next one is pi fourths if we keep going in order. Well, if you look down here, I don't see pi fourths. But if you understand how the unit circle works, if you look at your unit circle, pi fourths on your unit circle is directly halfway in between pi sixths and pi thirds. So basically, when we graph this, we're going to be graphing something that would be right about there. And then we got to get the actual decimal value for square root of 2 over 2. So a couple things that you need to know. The square root of 2 as an approximate decimal is about 1.4. So then if we divide 1.4 by 2 to get the square root of 2 over 2, that's going to give us about 0.7. So that's our approximation for the square root of 2 over 2. The square root of 3 is approximately 1.7. So then if we divide the square root of 3 by 2, or 1.7 by 2, we're going to get approximately 0.85. All the other values on here are relatively easy. You've got zeros, 1/2s, and 1s. We can deal with all that. It's just those ones with the square roots on the top that we have to actually do the approximations. So let's just fill those in. That's going to be 0.85 here because it's the same thing. It's going to be 0.7 here. And then over on the right side, that's going to be negative 0.7, negative 0.85. Over here, that's going to be negative 0.85 and negative 0.7. All the rest of them don't really need decimals. Again, because 1/2, well, we know that's 0.5. So the rest of these should be pretty easy. All right, so let's go ahead and finish graphing that first quadrant. So at pi over 4, we should be at about zero point 0.7. Again, pi over 4 is that little line halfway in between pi sixths and pi thirds. And zero point 0.7 should be about right here. It should be just below that 0.75. All right, the next one is at pi thirds. That should be about 0.85. Well, that's going to be someplace in between the 0.75 and the 1. Just do your best to approximate. It should be somewhere in the neighborhood, somewhere around there or so. It's close. And then at pi halves, we should be at 1. All right, so I've gone ahead and started graphing the first quadrant from 0 to pi halves. You guys continue to graph the rest of them. And again, realize that the ones that say the something over 4, it's going to be halfway in between your 6 and your thirds. So make sure you graph those correctly. Again, I'm going to fill in the rest of these. I suggest you pause the video and sketch the rest of them yourself before you take a peek at what it should look like. Okay, so if you pause the video and you've come back, the rest of these dots are now filled in, and you should see what looks like a pretty nice curve. All we have to do now is pretty much draw a line, or a curve, excuse me, right through all the dots to the best of our ability, and it'll look something like this when we're done. A nice smooth curve that looks like that. Now there's a couple questions I believe on the next page that it's going to ask you some things about this. Let me peek at that real quick. Describe the graph of the sine function. Can you predict how the graph will continue? And then it says the unit circle provides points from only 0 to 2 pi. Sketch the graph of the sine functions for values less than 0. All right. So can we predict what's going to happen here? Well, hopefully you realize that you could technically keep going around the circle forever. This graph should go on and it should continue in both directions. So if I kept going this way, and I'm not going to do it for real, it would continue to do the same thing forever. And then if we go backwards around the circle, it's just going to be basically the exact same thing in reverse. So you would expect, or hopefully expect, that if I went backwards, that the graph would start to go down to the left before it comes back up. So it's actually going to come and hit right here. And then it's going to start to come back up and hit right here. And then once it gets there, now it's going to go above the axis and it's going to hit 1 right here before it starts to come back down at negative 2 pi, and then it would continue on forever. So basically the sine curve is going to go on forever left and right. It just keeps on going. And it's going to keep going like that and so on off the graph. The best descriptor of this, and I don't know whether you can tell, it looks kind of like a wave, and that's what we call this. We call this the sine wave, and the other one for cosine will be called the cosine wave. This stuff, again, this is used every single day, and people don't even realize it because sound waves, things that you hear, those are sine and cosine waves. Light waves, things that you see that create the light, that's done by sine and cosine waves. It all has to do with the frequency of how quick the waves occur as far as what you hear and what you see. But yes, it is used every single day. You just don't even necessarily know it. All right, your job, your task is to do exactly the same thing with cosine. So remember that cosine is your x values. So you're going to go around and you're going to fill in all the x values. It's the same decimals because you should know that the square root of 2 over 2 and square root of 3 over 2 are going to repeat themselves. So it's exactly the same things there. Go ahead and fill in the rest of the chart. And then again, I'm going to pause mine. I'm going to fill everything in. So once you've had a chance to fill everything in, you can come back and check it out to make sure that you got it all right. And then we're going to go ahead and graph all of the points. All right, so as you can see, I've gone ahead and filled in all of the values now. And hopefully you have all those things filled in. We're going to go ahead and graph the ones that we have. Again, start at 0. So 0, 1 will be our first one. I'll help graph the first quadrant, and then after that, I'll let you finish off the other three quadrants. So at pi 6, we should be at 0.85. So pi 6, 0.85 is going to be somewhere around there. Remember that pi fourths is right in between pi sixths and pi thirds. That's 0.7, so that should be right about there. Pi thirds is 1/2, 0.5. And pi halves is 0. Okay, so go ahead and fill in the other three quadrants, and then we'll see if we can sketch this thing. And again, I'm going to pause it. I'll come back and it'll all be filled in. Okay, again, hopefully you paused yours, but now you can see that this is completely filled in. So we're going to go ahead and make a smooth curve through all of these. Starts to come down here like this. And I know I'm doing it backwards, just easier for me to trace it this way. And it finishes up there, something like that. Close enough. I kind of missed that one dot. Good enough. And then, as you should expect, this is going to continue in both directions. So if I were to continue it in the left direction, I am not going to graph every single one of those points, but I am going to graph some of the key points: negative pi halves, negative pi, negative 3 pi halves, and negative 2 pi. If you notice, there are really 5 key points that you have to graph, and those are the ones that lie on the x and y axis of your unit circle. As long as you know the general overall curve and the shape of it, it makes it really easy, and you don't have to do every single one of the values in between. As long as you know the 5 values around the unit circle that lie again on the x and y axis, it just makes it a lot easier. So then if I were to connect all those, again, using a smooth curve, oops, I should have done that in red. Let's erase that. So I'm just going to dot these. Yes, this is part of the graph. It's just not part of the original part that we graphed. And then it curves like that. So it looks something like that. And then it keeps on going forever. So this is your cosine curve. So a couple of the takeaways. The sine curve, if you notice, go back to the sine one. The sine curve started at 0. It went up, then down, and then back up again. The cosine curve started at 1, goes all the way down to its smallest point, and then back up to its highest point. So hopefully you can tell by looking at it, we're going to be dealing with things like the maximum and the minimum, and things which are called the midline and the amplitude, and all that stuff is technically on your next page. So we're going to talk about those things before we get to our third video, but I think for the most part, this stuff should be pretty easy. So let's talk about these things on the next page now that we have somewhat of an idea of the sine and cosine curve. Again, the biggest takeaways: sine will start at the origin, at the middle, and go up and then down and then back up again. Cosine will start at its maximum. That's the general basic case. Things are going to be shifted. We're going to move them around, but for now, that's what we need to know. So let's talk about a couple of things. We're going to talk about this thing which is called amplitude. Okay, the amplitude is actually a distance. It is a distance from what is called the midline, which is below, and we'll define that in a second. It's the distance from the midline to either the max or the min. And a distance is always positive because it's a distance. You can't have a negative distance. That doesn't make any sense. But a distance is always positive. So when we define it, we are going to define the distance as always being positive. So it's always positive. It does not matter if there's a negative attached to our amplitude or not. It's going to be always positive value. The period and the midline. Let's define the midline first. We'll come back to the period. The midline is literally going to be the middle of the graph. The easiest way to define it, it is halfway, or yeah, I guess halfway between the max and the min. So we'll say it is halfway between the max and the min. So if we just go back real quick and look at the sine curve, it is pretty easy to see that the maximum is right up here at the top, that's 1. The minimum is right down here at the bottom, that's -1. The halfway in between is going to be 0. Okay, right halfway in between 1 and -1 is 0. So this is actually the midline. If I were to put a dashed line right through 0, right there, that's the middle of the function. It basically cuts the height of the graph in half. So the top to the bottom. So that's your midline. And it's going to be exactly the same idea with cosine. Again, the max is 1, the min is -1, halfway in between that is 0. This will come into play much more when we start moving the graphs up and down or stretching the graphs and stuff like that. And you'll be able to see that the midline is not always going to be at 0. The midline, however, is an equation because it is a line. It will always be in the form of y equals something. Okay, whatever that number is. In our case, the ones that we just looked at for sine and cosine were y equals 0. The midline will always be y equals something. It is so important. So when I ask you for a midline, do not tell me that the midline is 4. The equation is y equals 4 all the time. It's y equals something. All right, the last thing is the period. The period is the amount of distance for the function to complete one full cycle. Now, what the heck does that mean? The amount of distance for the function to complete one full cycle. We're going to go back to both of the graphs, and I'm going to show you what that means. If we go back to our sine curve, the amount of distance for it to complete one full cycle, I'm actually going to use the highlighter option here so we can show this. Here's the important thing. You can technically start anywhere to count this. It makes the most sense for us to start at the y-axis because it's the easiest place to count from. So if I were to start at the y-axis, in order for sine to complete one full cycle, it needs to go through the max and the min. So if you trace it, it's got to go through the max and the min before returning to the starting level. Well, we're going to start here at 0. I'm going to trace it. I'm going to go up here. Okay, I've gotten to the max. Keep going. Okay, now I'm at the min. Now I got to return to the starting level, which is right there. So how far did that have to go? Well, it went from 0 to 2 pi. So our period was 2 pi. It took 2 pi from left to right to go through one full cycle. And then basically it's going to start to repeat. It's going to do the same exact process over and over again. Let's look at cosine. Same idea. I'm going to start at the y-axis. Okay, this one actually starts at the max, so I've already hit the max, so we're good there. I've got to go through the min. Okay, down here's the min. Now that I'm through there, I've got to get back to the starting level. Not 0 necessarily, but the starting level where I started at, which is up here. Once again, that goes from 0 to 2 pi, so the period is 2 pi. It will not always be 2 pi, but a general sine or cosine function is 2 pi if it hasn't been shifted or anything else. And that's because if you think about it, the unit circle goes from 0 to 2 pi. So it takes 0 to 2 pi to go through one full cycle before it starts to repeat. So those are your 3 things that we're going to talk about when we come back in our last video, which should actually be much shorter than this one. Yeah, we'll come back with the last video, and we're basically just going to rehash those 3 things.